Yeah. Well, thanks to the JRC for hosting this event, giving us a chance to try to be users of Inspire for a change. Usually we're in some kind of a support mode, so now we got to be users. And yeah, this time we're the first of, I think it was just a coincidence, not conspiracy, that it's only Canadians on this one. So I'm going to talk to you about the Flood Warning Assistant. And don't worry, you're not going to, I know the slide yesterday was quite busy because I tried to put too much on. I'm not very good at doing only one slide, so these ones are a little more manageable. So we wanted to find something very practical to use for Inspire, and sort of a universal problem that many people have. So it doesn't matter if you're in Canada or in Europe. One of the biggest impacts due to climate change is extreme weather, and with that comes the possibility of more severe flooding. And in many contexts, the historical flood maps are not very helpful because they don't predict the future. And there's some great Inspire data that we found related to floods, but one of the challenges is, well, how is that data accessible by the public? Or how is that data accessible in a developer-friendly or web-friendly form? So really, there's a couple things going on here. We wanted to leverage Inspire data, the base map data, but also enrich it with real-time information and make that available on a web or mobile-friendly way. And so that's kind of the context for our challenge. Some of the data sources that we are working with, historical flood information. We ended up working with a lot of UK data just because we found that there was quite a bit that was free and easily accessible. But we did also use some Finnish data we accessed from the National Land Survey via their WFS3. So we've got historical flood information, live flood warnings, and then after that we thought, well, what's really interesting in terms of getting value out of the data is the synthesis or the combination. So it's not just getting real-time data combined with historical, it's, well, what's the actual impact? So to kind of enrich that view, we thought what would be some useful data layers, base map layers to intersect with the flood extents. And so we started off with road networks, arterial roads and interchanges, and then we added some infrastructure layers related to things like schools, hospitals, and places of refuge. And here you can see the flood warning areas, and I'll just pop this open so you can see what it looks like. So the flood warning areas are on the geoportal, but there's no, you'll see here, there's no link to access the actual service. So I would say this is sort of an experience that we came across several times where the geoportal was useful to research some of the metadata about what's available, but it didn't actually tell you how to use it. It was somewhat incomplete. And yeah, so there's no, now what we could do is basically take the information from that form, the flood warning areas, and then we could Google that and find, oh, you lose the screen. Okay. Oh, that's not. Yeah, so if I basically take the flood warning areas and then put that into Google, then you actually get the national geoportal for that data. And so you could argue, well, there was already a service available, but it's a bit, obviously it's a fairly focused use case, and it doesn't do anything related to some of the detail extents or the impacts. Let me get back to my slide. I'll try not, maybe I'll just stay in the deck for now. Sorry. So same thing here. I'm just showing when I search for open roads in the GeoPortal, I got about 21,000 hits. I don't know if I'm just not using, maybe I'm not using the right notation. When I search for a single word like open or roads, it was a bit more focused. So searching on just roads gave about 35 hits, and then if I scroll to the bottom, I actually got the Ordnance Survey open roads that I was looking for. So the data is there, but some challenges around search. Again, when I put it into Google, it comes up on the first record. And then I was using the UK OS Open Map Local. The other comment I'll make about this data, I like to call it sort of Inspire Plus. When you look at the namespaces, you see that there are Inspire namespaces and also Ordnance Survey namespaces. So they're using the Inspire as the core standard, and then they have essentially an extension on that for UK specific things. So that's a pattern that we saw, and we noticed that on when we read the schema. Initially, I wasn't sure which of our readers to use for it, so to double check, some of these files were like a gigabyte, and I couldn't open it up in an XML editor, so I had to use FME to read the first, say, 1,000 lines, write it to a temp file, and edit that to see the header. So you can see the tiles. If you play around with the demo, I only use tiles S, J, K, O, and P, which are the center of England down here. I could easily add to that. Maybe I will over time. But even that was like 4 or 5 gigabytes, so it's quite a bit of data. That's the basic architecture diagram minus all the busy screenshots that I had added to it. So let me just walk you through really quick. Just keep track of time here. So basically, we read the flood warnings from the UK Environment Agency. They have a REST service. It's not a WFS3, but it's very much like that because it has a JSON service that you query to get feature IDs, and then you query that, use essentially a get feature to pull back the geometry or GeoJSON. So it's a couple of transactions to get the data you need. We're loading that into a staging database in GeoPackage. And there was some talk yesterday about alternate encodings of Inspire. So GeoPackage is certainly good for when you're getting into larger data sets, because obviously GML is not indexed in any way, and there's performance hits if you try to deal with very large data sets, whereas GeoPackage scales a bit better. And then we're loading some Inspire base map data, WFS3 from National Land Survey, and then this Ordnance Survey, Open Roads, and open Map Local for infrastructure. So we basically have 2 main steps here: extractor and loader to load that into the staging database, and then the flood service query, which the flood query runs every hour and updates the current flood table. And then every day I archive the flood table into past flood. So over time it's building up a history. And then on the client side, if you think of this as your web client, so that's just a JavaScript web client. What it does, it interacts using a REST service that's based on FME server. It interacts with the database, and basically based on the user parameters, they can choose to inspect current floods of different severity or historic floods, or if they want to, once they find some floods that in an area of interest, they can see what the potential impacts of those floods are. And this is all, so this is web friendly because it's just a JavaScript client, and it produces HTML reports, which again any mobile device could display. So I won't get into too much detail on the workspaces, but those are the the three main steps that I just went through. These are just some of the database loaders. The key thing I'm going to mention here is that we have this is for loading the roads, and so we take maybe more than half a gigabyte of data, but all we care about is the arterials. So again, I'm trying to make an application that will scale. So if you're trying to maybe evacuate, you'd probably want to know what arterial routes are open or closed. And the OpenMap local, again, this has every single building in UK, so it's a very large data set. We filtered it down to just the functional sites, so that's where the schools and hospitals, clinics are, and things like tunnels and transmission lines, things like that. And this is kind of just a bit of a prototype WFS3 reader. We will probably in the next couple months we'll have kind of a proper WFS3 reader but this just shows the flexibility of FME when you have a new standard coming out like WFS3 or some of the other open API. We can interact with them out of the box, and then over time we will kind of streamline the user experience and add some GUIs to that. So yeah, then once all the data is in there, this is the workspace that actually generates the HTML reports. And the one thing I'll mention, wouldn't expect you to be able to read this, but there is a sort of a repeating pattern here. And we actually built a series of exercises. So that's one of the things I was presenting on this morning. We took the data challenge and we actually used parts of this in our tutorial or workshop this morning. And one of the exercises is I take the impact data and I add a new class of impact. So it's quite an extendable platform because we have like roads and interchanges. And then to add a generic, like an infrastructure layer, was just adding like 5 new transformers across the bottom that basically I just duplicate the spatial relator here. I add a new spatial relator, take the infrastructure output, connect it up, and now I have a new class of impact. So it's fairly easy to extend. So this is the GUI to query for floods. This is the result, flood information, and then you can look for the impacts, and that's the interface to FME server. This is all running on AWS in the cloud, so it scales fairly well. Just keeps going. So I think a couple minutes left. I'll just fire this up and just show you how it works. So I can change, this is just happening in JavaScript where I can change the size of that circle and look for past floods. So this is just leaflet on the front end in JavaScript, but as soon as I click submit, that's interacting with that REST service on the server and pulling back these historic floods around Birmingham. So it just so happened that, as you saw from that BBC article, that the time of this challenge happens to also be a time of a lot of floods in the UK. And so you can see the flood IDs and the dates for those. And then if I go back, now that I know there are some floods in that area, I can then uncheck, I can choose which impact type I'm interested in. So in this case, roads. So it'll look for roads that might be influenced or at risk due to flooding in that area. And then we'll look at some infrastructure. So I would have liked to have found a little bit more data, like for Finland as well, but kind of ran out of time. So these are the roads, and so it actually tells you what the name of the road is, as well as the flood ID that might threaten that road. And so if you're in this area here, you might decide to evacuate along this route and avoid these arterials because those ones might, have some water impacting them. And then the last thing is infrastructure. And you know it's working when it takes a little while. So if you don't have any floods, it comes back with a, oh, nothing to see here kind of warning, but that's very quick. So don't worry, if you want to play with this yourself, you can select all of England and it'll take a while, but it's not going to crash, it just keeps running. So here around Birmingham, you can see here's a college that might be at risk with those floods, a couple different schools. A lot of that seems to be school related. Yeah, so maybe the kids get off of an extra day off school so they don't have to get wet. So that's basically the idea of the application. Well, I guess because we are here in Helsinki, we have to do at least 1 or 2 queries here. So we'll see where does it get wet around Helsinki. And you could see that over time you could add data for other countries. So I think we are around here, so maybe the closest floods were, now this has only got historic data. I could tie in current as well, but this is showing 2018. So almost exactly the same time, but in a year ago, there were some significant floods just to the east of here. Okay, so just to wrap up, I just wanted a few comments on challenges and lessons learned. Okay, that's that scary slide from yesterday. So I would say that the Inspire Geo portal is useful in the sense that it's this huge index of available data, but it's not necessarily, it's useful but not sufficient on its own. So it provides some information about what data might be available, but at least from our limited experience, there was missing links to some of the national agencies that actually held the data. Didn't have time to review everything, but there were some cases where we were looking at WFS2 services, but we didn't have access permissions. So that was another issue that came up. And in general, there's a lot of very useful information, even at the national level, but if to a casual user or even a developer who's not really familiar with it, it would be maybe difficult to leverage. So some of those huge GML data sets on their own, you're not going to deploy them on the web. You have to think of some way of, in this case, encoding, be it in GeoJSON or HTML for those tables. So different ways of encoding that data, filtering the data to make it usable. So these huge data sets on their own are a bit unwieldy. Yeah, and you can see like for 1.8 gigabytes of data, or about close to a gig for roads, we filtered that down, and the amount of data we were actually using was in the order 20, 30 megabytes. We did a bit of processing on the way. So with the roads data, we had to come up with a composite name that we could aggregate the roads, because initially I had hundreds and hundreds of hits, because every single road segment was a separate record, so we had to unify that. And yeah, the Inspire schema, figuring out how to map that to something that you can fit on a web form. And initially I had some trouble even with the coordinate system. So some of the data was in a British National Grid, which didn't line up with lat long, so we had to reproject. And yeah, figuring out which namespaces to use. So just to sum up, and then we'll have a couple minutes for questions. So I think there's a huge potential with the Inspire Geo portal and the other Inspire resources. And the basic search, we found a high-level search by country or by Inspire theme was a good start, but some of the detailed searches we had some difficulty with. And typically it was the national geoportals where we actually got the data, but even from them, there were some limits to how it could be used without filtering it further. And we found that doing this on a cloud basis seemed to scale really well. So not having to worry about managing something on premise. And ultimately, I think we learned a lot from this whole exercise. It was a good experience, and bang our head against the wall a little bit with living life as a user for a change instead of supporting the users. And I think we managed to build at least a starting point of a web-friendly, mobile-friendly client that allows people to interact with flood data and also look at some of the impacts, potential flood impacts. So, and I think it is an interface that would be scalable and extendable. So thank you for your time.
Any questions?
Sure.
So you said that not many of the UK metadata references had actual downloadable data. How easy did you find it to get it from using Inspire as your base?
Yeah, I kind of walked through that a little bit. So the keywords that were in the metadata were enough that if I copy them over to Google, I could find the data. And then I do have to admit that once I don't know if I have a screenshot of it. Once I got to, oh, I lost it again. Sorry. It keeps flipping out on me. Try that again. I have to admit that the Ordnance survey web portal was pretty, overall is fairly easy to work with. So this here is where we ordered the data. And of course, it takes a while to download. They're huge files. But basically, you just get a form, you fill it out, they don't charge you any money, and you have tons of data. I found that OpenMap Local one of the most useful because it has so many different themes. But there was also the names, roads, rivers, and a lot of them are based on Inspire but have this national extension to it. And fortunately, FME is able to read more or less any GML, any well-formed GML, but you can also get it as shape or geopackage as well from that portal. Yeah?
Did you consider the depth of the floods at all? The depth of the floods?
No.
Flood extent is one thing, but a 5 centimetre deep flood is very different.
Yeah.
25
We're just getting the data from the UK Environment Agency. It deals with the severity of the flood, so that would have something to do with the depth. So you can choose, like in the web app, you can choose the level of severity that you're interested in, whether it's alert, warning, or expired. And I think in the text it talks about how deep, so there's a textual description of how deep that would be. But it would be, I mean, right now, like, we're not doing the flood modeling, we're just querying the service.
Yeah.
And if they had a structured way of tagging the depth of the flood, we could certainly pull that out. If it was somewhere either in the GML or if there was metadata, XML data associated with it, we could pull that out. And yeah, that would be a good dial to add to this interface and say, well, I don't care about 10 centimeter, 30 centimeter flood, but if it's more than 1 meter, that could be a serious problem because I can't drive anywhere. So that might be useful to add. It's a good idea. Yeah?
I have the impression, probably wrong, that I don't care to share, that the fact that the Inspire portal is not allowing to detect any useful downloadable link is not the problem of the Inspire portal. It's the problem of how the data provider is filling in the metadata. So if you find a dataset in the Ordnance survey web portal but not in the Inspire portal, I would say it's an issue of Ordnance survey, not of the Inspire portal.
Sure, that's a fair point, because they're the ones submitting the data, and for whatever reason, yeah, if they're not putting it up there, maybe they're worried about the whole world coming to them. And
just to comment on that, I sort of agree, but I still disagree. Because for the user, it doesn't matter whose fault it is.
Yeah.
It should be that the geoportal then has to have some sort of quality assurance mechanisms to make sure that the metadata providers actually provide this information. So it's so easy to say that it's not our problem, it's the data they're doing bad metadata, but the end user, Dean here, did not find what he was looking
I agree
for.
and I disagree with you.
Okay. Being the coordinator of geoportal, I can just share with you that we use your feedback. Thank you very much for it. It's an excellent feedback from the real application, from the user side. And we shared it with the member states last week already to demonstrate, look, these are the requirements for your data and the quality of data and services. So we are in that process really to work together with the member states to satisfy your needs. So just
Excellent.
yeah, and even if it didn't provide a link directly to where you can download, but it just had a link to the authority, that was resolvable. Like even to the home page of the UK Ordnance Survey, then at least you might be able to go contact information, find someone. But yeah, I mean, certainly we're not passing any judgment, like you said, just from a user perspective. We kind of hit a dead end, and then we have to go look in Google, hunt around. So it's not terribly efficient. I think it's a good start, because at least you can find out what is available. You might not even have a clue what to Google for before you have the geoportal. So I think it's a good start, but I mean, I think it should be part of, ideally it would be part of the requirements if you're going to submit metadata, that you actually provide a resolvable link of some kind.
Well, many of
Especially
those
if there's-
requirements are in the legal framework and are legal required.
Yeah.
But still, it doesn't work. So
Okay.
Okay,
Thank you. Thank you,
thanks.
Dean.